So this week's experiment is aspirin synthesis and analysis. What you're going to observe now are the two main parts of the reaction. The first one is the synthesis of aspirin. So I'm going to prepare or synthesize aspirin in the lab. So for the analysis portion of the lab, I'm going to analyze two commercial aspirins. So I'm going to use the Bayer brand, which is the name brand, and the generic brand Up and Up. And I'm going to test it against the crude aspirin that I prepare in the lab. Come on, let's learn. Where I'm going to be preparing my aspirin. Okay, so to begin weighing my salicylic acid, I have to use a piece of weighing paper. Alright, so I'm going to fold the weighing paper diagonally like so. You always want to protect the balance pan with a piece of weighing paper or a weighing bowl. So I'm using a weighing paper today. So next you would look on the balance display and it's reading 0, so that's perfect. I then open the door. I put the weighing paper on the center. Okay, close the doors and tear the mass of the weighing paper. Okay, so now the display is back to 0. Now what I'm going to do is I'm going to weigh out a little under a gram of the salicylic acid, so that's the main ingredient used to make aspirin. So I'm picking up my weighing paper, both hands. So the next thing that I'm going to do is I'm going to add the second main ingredient, which is acetic anhydride. Right, so my acetic anhydride is inside a burette. Here's my salicylic acid. I'm going to open up the stopcock and add about 2 mils of the acetic anhydride. Okay, so my last ingredient that I'm going to add to make my aspirin is 85% phosphoric acid, H3PO4. Phosphoric acid is going to serve as a catalyst. A catalyst is something that speeds up a chemical reaction. Okay, so next step is to fill a 150 ml beaker with crushed ice and cold tap water to the 100 ml mark. Okay, so here we go. Okay, so whenever you're making an ice bath, you want a lot of ice and just a little bit of cold water. Okay, so while I'm waiting for the reaction to go to completion, I'm going to do step 8. So put 6 mils of deionized water into a 10 ml graduated cylinder. So once the heating is over, I'm going to add a dropper full of water from the grad cylinder to the reaction mixture. wafting method. And what I'm smelling is a very strong odor of basically vinegar. So that is the acetic acid. What I'm going to do now is I'm putting my reaction vessel into an ice bath for 10 minutes. So during the 10 minutes, we should see crystal formation. So I'm going to check on my reaction vessel after about a minute or so to ensure that crystals are forming. So while waiting for the crystal formation, I'm going to weigh a piece of large weighing paper. So this is where crystals of aspirin will be transferred onto. By the cloudiness, that crystals indeed are forming. And I'm going to give it a stir just to ensure crystal formation. So I'm scratching the inside of the test tube. I want to show you vacuum filtration technique. So the vacuum filtration technique is another way we can use to isolate the crystals, so to separate the solid from the liquid. A ring stand, all right. Then we have 2 filter flasks with the side arms. So the first filter flask serves as a water trap, and it has a rubber tubing connected to the vacuum line. All right. Next, we have the 3-prong clamp to hold the filter flask in place. And then we have a smaller filter flask, again with the rubber tubing. Okay. And we also have something called a Buchner funnel. And then we just have the rubber adapter, which keeps the Buchner funnel in place. So we want to make sure the seal is nice and tight. You'll know the vacuum is on by the hissing sound that it makes. So back halfway. Crystals inside the test tube. So my last step will be to isolate the crystals by vacuum filtration. Alright, then you want to use a minimum amount of ice cold water because aspirin is partially soluble in room temp water but not ice cold water. For the vacuum filtration to proceed for 2 minutes. After the first 2 minutes are up, I'm going to rinse the crystals to remove any impurities, specifically acetic acid. By spraying water all over the crystals. Again, I'm using my ice cold water. Okay, so now we're doing the second rinse of the crystals. Again, when you rinse the crystals, you want to rinse them completely, not just in one spot. and I'm gonna time the reaction for another 2 minutes. Okay, you can notice that the aspirin crystals are becoming more pure because the acetic acid, the vinegar smell, is not as prominent as before. Okay, so now that the vacuum filtration is complete, I'm going to shut the vacuum line off all the way. So the next step, I'm going to remove the crystals onto my large pre-weighed weighing paper. Now I'm using a metal scoop to scrape off the crystals. Okay. Next, I'm going to break up the clumps so that the crystals dry quicker. Okay, so next I'm going to bring the crystals and put them under the heat lamp until they're dry. Okay, so you can see that the crystals are not as clumpy anymore, and if I touch them, they don't stick to my fingers, so that means they're pretty much dry. So this completes the synthesis portion of the lab. So we have a total of 4 tests that we're going to do. The first one is a solubility test. So we're going to see if aspirin is soluble in water. We're going to test 2 commercial brands. The 2 brands are the name brand, which is Bayer, okay, and the generic brand. Okay, so this is Up and Up. So we got this from Target. And of course, we're also going to test the aspirin that we made. My commercial aspirin is in tablet form. I will use my mortar pestle to pulverize or turn it into powder. Allows me to obtain literally a few grains of the aspirin. So I don't want to add a lot for this amount of water, so I'm using about 10 drops of the deionized water. That the solution is cloudy, right? So, and there's some crystals, undissolved crystals on the bottom, so we can Bayer aspirin is only partially soluble in water. There are crystals on the bottom. All right, and lastly, my crude aspirin, and that one didn't dissolve very much. All right, so this one's not very water soluble at all. What I'm going to do now is I'm going to do the iron 3 chloride test, which tests for the purity of aspirins. And for this particular test, I'm going to be testing again the 3 aspirins, so the Bayer, the generic, the crude aspirin, and also we have a control. So the control does not have any aspirin, it only has water, and it's going to have a drop of the reagent. And my reagent is 10% FeCl3, which is iron 3 chloride solution. Starch test, and so we're using the iodine starch indicator solution. All right, what I'm going to do now is add a drop of the starch indicator to my 3 aspirins and to my control. Okay, so as expected, my 2 commercial aspirins, the Bayer, which is the name brand, and the generic, have turned a blue-black, so it's mostly black in color. And the reason for that is because both contain starch. You can see that deep black color. So my crude aspirin did not turn blue-black, as it does not contain any starch. And how can we tell? It's always nice to compare the colors. Whenever you do a color test, you compare to the control. And my control is only probably a light orange color. All right. Okay, and for the acid test, I have already added my 10 drops of the sodium bicarbonate, which is the base, and then I added the aspirin. So now I'm going to start adding drops of 6 molar HCl, which is hydrochloric acid, and we're going to note the bubbling. We're going to count the drops it takes for the bubbling to stop. So that was about 5 drops. Okay. Now we're going to test the generic aspirin. Okay, this one was about 8 to 9 drops. All right, and let's check the last one, which is the crude aspirin, the one that I have prepared. And I would say this one is took about 12 drops for the bubbling to stop. Conclusion of our acid test, we can see that all of the aspirins are acidic, or at least slightly acidic, and that is true because aspirin does contain a carboxylic acid functional group. And so my Bayer aspirin is moderately acidic. Probably the generic aspirin is a bit more acidic, and the reason for that is if you look at the expiration date, it is 2013, and currently it's 2020, so it's a bit old, all right? So it degraded a bit. And of course, my crude aspirin is impure, so it is the most acidic out of the 3. Okay, so let's see, 3rd test, 4th one. All right, and looks like everything is complete. So this concludes the analysis portion of the aspirin.